Okay, this objective is to connect area models and distributive property to the partial products of the standard algorithm with renaming. Okay, draw an area model, then solve using the standard algorithm. Use arrows to match the partial products from the area model to the partial products on the algorithm. Okay, first thing we're going to do is we're going to draw ourselves an area model. And we're doing with renaming. So now we have 273 times 300. So the first one here, I'm going to have 200, 73. And the second one is a little different because you do not represent 0 on an area model because it is an area model and no way you would represent 0. So we'd have 306. Now, in order to start working the standard algorithm right here, the first thing we would do, we would start with our 6 right here. So that's what we're going to do in our area model. So we know 6 times 3 is 18. 6 times 70, we're going to have our placeholder, and 6 times 7 is 42. We have 6 times 200, we have 2 place values, and 6 times 2 is 12. So when we added this partial product up here, we'd have 8, 0, so it'd be 8. We got 1 and 2. 1 and 2 is 3. We have 4 and 2 is 6. And we have a 1,000. So we know that the product of 6 times 273 would be 1,638. Now we're ready, since there is no tens, we would go to our 300s. And we're going to start with 300 times 3, which we'd start with 2 placeholders because of our 2 and 300, and we'd have 3 times 3 is 9. And once again, this time we have 2 and 1 on top, so we're going to have 3 placeholders. And 3 times 7 is 21. And here we're going to have 4 placeholders, 4 zeros, 1, 2, 3, 4, because 2 in each product. And 2 times 3 is 6. Now when we add these together, we can see we're going to have 0, 0. We're adding them up, 0, 0, 0, 0, 0, and 0. Now we got 9, 0, and 0, so that's 900. And we got 1,000 and 0, so that's 1. And we have a 6. So we know that this is going to be 61,900. Now we're going to, this here would be 300 times 273. So we can see this is our partial product for here, and this is our partial product for here. When we add them together, we end up with 8, 3, 9 plus 6 gives us 15, carry 1 is 3, and our answer will be 63,538. Okay, question 2 is to solve by drawing the area model and using standard algorithm. Okay, so we're going to start by drawing our area model. We're going to draw a larger one this time. We have more space. Now, going across the top, I have 7,018. Remember, we do not represent 0 on an area model. So we're going to split this up into 3 sections because we have 3 place values that have digits greater than 0. So this one's going to be 7,000. We're going to have 10 and 8, 7,018. Now, once again, keeping under the same thing that we're not going to have a place value for 0, we're going to have 209. So here we got 7,018, and we're multiplying by 209. So what we're going to do first, we're going to solve it with the area model, then we're going to solve the standard algorithm, and we're going to match the products. So first we'd start with a 9. So 9 times 8 would be 72. 9 times, put the placeholder, 9 times 1 is 9. Under 7,000 we have 3 place values, and we have 9 times 7 is 63. When we add these up, in the ones places we only have 2. In the tens place we have 9 and 7, which is going to give us 16. There's no hundreds here because we had to carry our 1, and we're going to have 1. And then we have a 3,000 and a 6,000. Now the second one we're going to do is 200 times 7,018. So we're going to start with 200 times 8, which we're going to have 2 zeros and 16. And the second one we got 2 here and 1 up here, so we're going to have 3 zeros. And 2 times 1 is 2. And the last one we're going to have 5 zeros because we have 5 multiples of 10. And then 2 times 7 is 14. We add these together, we can see in the ones place we have 0. In the tens place we have 0. In the hundreds place I have 6. In the thousands place I have 3. And then I have 140. When we add these together, we've got 2, 6, 7, 3 and 3 is 6, and we got 6, 4, 1. So we ended up with a 1,466,762. Now let's try the standard algorithm, see how it matches. 9 times 8 is 72, carry our 7. 9 times 1 is 9, plus 7 is 16, carry our 1. 9 times 0 is 0 plus 1. 9 times 7 is 63. And here you can see both partial products are the same. Now we know we don't show zeros in area model, so we're not going to put that in here. And then so in order to multiply by 200, we're going to have to put 2 placeholders in there. Now we're going 2 times 8 is 16, carrying our 1. And we have 2 times 1 is 2, and 1 is 3. 2 times 0 is 0. 2 times 0 is 0. And 2 times 7 is 14. And you can see we have the same partial products, 1,403,600. When we add them together, 2, 6, 7, 6, 6, 4, 1. 1,466,762. They match. 3 says solve using the standard algorithm. Okay, so no area model this time. We're doing 1,426 times 357. Now we're starting off with a 7 just like we do in our area model. 7 times 6 is 42, carry our 4. 7 times 2 is 14, and 4 would be 18, carry our 1. 7 times 4 is 28, and 1 is 29, carry 2. 7 times 1 is 7, and 2 is 9. Now what I like to do at this point is I like to line these out when I'm done, because I'm going to have a couple carries through this, and I don't want to get confused. Now we're going to 50 times 1426. So before I can do that, I want to put a placeholder. Now it's 5. 5 times 6 is 30, carrying my 3. 5 times 2 is 10, and 3 is 13, carrying my 1. 5 times 4 is 20, and 1 is 21, carrying my 2. And 5 times 1 is 5, plus 2 is 7. Now I'm going to go up here, and once again, I'm going to line them off after I'm done so I don't carry them wrong. Now the last one is 300 times 1426. So I've got to put 2 placeholders, so I can just go 3 times 6 is 18, carry my 1. 3 times 2 is 6, and 1 is 7. 3 times 4 is 12, carry my 1. And 3 times 1 is 3, and 1 is 4. And here I have 2, 8, there's 12 and 20. Here are my 2. There's 11, 12, 19, 9 and 10, and 5. Now we got 509,082. Now, remember what we did before when we were doing things? If I was just using a standard algorithm, I'd be using an estimation to make sure my answer was reasonable. Okay? And if you remember the way we did that, that's not part of this problem, but it's a good practice you should be getting into. If I have 1,426, I'm rounding it to the closest thousands. So 1,426 is closer to 1,000 than it is 2,000. So I'm going to round it to 1,000 times. 357 is closer to 400 than it is 300. Now I can see that I've got 3 zeros and 2 zeros, so I'm going to put them over here. 1, 2, 3, 4, 5. 1 times 4 is 4. And I can see that my answer to 1,426 times 357 should be approximately 400,000 to be reasonable. And you can see we had 509,000. And that is reasonable because we rounded down to 1,000, so it should be more than 400,000. That's the way you should be using estimates to verify whether your answer is reasonable or not. Number 3, C. Now this time let's do the estimation first. Okay, so 426, that's closer to 400, times 307 is closer to 300. So we know that we're going to have 4 zeros here. 3 times 4 is 12. So we know this answer, 426 times 307, should be approximately 120,000. Okay, so let's work it out and see if it's reasonable. 426, 307. 7 times 6 is 42. 7 times 2 is 14, and 4 is 16. 7 times 4 is 28, and 1 is 29. Now we're doing 300, so we're going to have to put 2 placeholders. 3 times 6 is 18. I'm going to line them out first. 3 times 6 is 18, carry my 1. 3 times 2 is 6, 1 is 7. And 3 times 4 is 12. When we add them up, that's 2, 6, 17, carry my 1, 10, carry my 1, 3, and 1. So this came out to be 130,762. We said it should be approximately 120,000. That is a reasonable answer. All right, let's continue this because it's good practice. If I have 1,426, I know that is closer to 1,400 times 307. I know that's closer to 300. So I have 4 zeros, 1, 2, 3, and 4. Okay. Now 3 times 4 is 12. Carry my 1. 3 times 1 is 3, and 1 is 4. So our answer should be close to 420,000. So this would be approximately 420,000. Now, let's see how it works out. 1,426, 307. 7 times 6 is 42. Carry our 4. 7 times 2 is 14, and 4 would be 18. Carry our 1. 7 times 4 is 28, and 1 is 29. Carry 2. 7 times 1 is 7, and 2 is 9. Now we're doing 300 here, so we're going to put 2 placeholders. 3, and let me go ahead and line these out before I get started. 3 times 6 is 18. We carry our 1. 3 times 2 is 6, and 1 is 7. 3 times 4 is 12. Carry our 1. 3 times 1 is 3, and 1 is 4. We add them up. We got 2, 8, 9, and 8 is 17. Carry the 1, which is 17. Carry our 1. 2 plus 1 is 3, and 4. So we ended up with 437,782. And we said our estimation should be approximately 420,000. That is a reasonable answer. Question number 5. On Saturday at the farmer's market, each of the 94 vendors made $502 in profit. How much profit did all vendors make that Saturday? All vendors. So now I'm going to do a drawing, and I like doing a tape diagram. On the top of a tape diagram, that is always the total of whatever you're trying to solve. So this is going to be total profit of vendors. Now, we know that there are 94 vendors. So I can put like this, put an arrow, I put 94 vendors. That just lets us know there's 94 sections here. And in each section was $502. So to solve this, we can see we have 502 times 94. So now let's take 502 times 94. 4 times 2 is 8. 4 times 0 is 0. 4 times 5 is 20. Now we're going to go 90, so I'm going to put a 0 in here so I can use my basic math facts of 9. 9 times 2 is 18, carry 1. 9 times 0 is 0 plus 1. 9 times 5 is 45. And we end up 8, 8, 1, 7, 4. So according to this, the total profit of the vendors was $47,188. Now let's do the estimation, see if it works. 502 would be closer to 500. 94 would be closer to 100 than it would be to 9. It should be closer to 90 than it would be to 100. So when we multiply this, we can see it's going to have 3 zeros, and 9 times 5 is 45. So about approximately, so this would be approximately 45,000. And we found out our actual answer was 47,188, which is reasonable.